Vertical line on screen is representing wall and horizontal line is representing ground or floor. There is a ladder which is leaning against wall and it is falling down. Let us say wall, floor or ground is link number 1 and it is fixed, means it will not move, while ladder is link number 2. At point A, ladder is having contact with wall, and at point B, it is having contact with ground or floor. Ladder which is leaning against wall is falling down. Therefore, velocity at point A on ladder, that is VA, will be in downward direction, and velocity at point B, VB, will be directed towards right. Link number 2 is moving relative to link number 1, or we can say ladder is moving relative to fixed link, that is ground and wall. At this instant, this motion or movement can be treated as pure rotational motion about imaginary center or virtual center, and that center is known as ICR, that is Instantaneous Center of Rotation. Now we will locate ICR for relative motion between body 1 and 2. It means we have to locate I12 or I. How to locate ICR, I12 or I? We will draw a line perpendicular to VA. Now we will draw a line perpendicular to VB. At the intersection of these two perpendicular lines, we will have ICR, I12 or I. By observing I12, VA and VB, we will come to know that link 2 or body 2, that is ladder, will rotate in anticlockwise direction at this instant about ICR, I12 or I. Body 2 or ladder is moving relative to body 1. Body 2 is having pure rotational motion about center I12. If it is difficult to imagine, then we can assume any shape for body 2 and still it will rotate about ICR I12, because links can have shape in any manner. Or we can assume body 2 as a part of circular disc which is rotating about ICR I12, or we can assume body 2 as a sticker which is pasted on circular disc and that disc is rotating about ICR I12. Now consider point C on ladder or link 2. We are interested in velocity at point C, that is VC. Velocity at point C will be given by using basic relation V is equal to R omega. Therefore, VC will be equal to distance between I12 and C multiplied by omega 2. So relation for VC is equal to I12C into omega 2, where omega 2 is instantaneous angular velocity of link 2 or ladder, or we can say omega 2 is angular velocity of link 2 or ladder at this instant. Or we can have relation VC equal to IC into omega 2, and velocity at point C will be perpendicular to I12C or IC in the direction shown on the screen. Similarly, we can write relation for velocity at point A, that is VA. VA will be equal to I12A into omega 2, or VA will be equal to IA into omega 2. And velocity at point B will be given by relation VB equal to I12B into omega 2, or VB equal to IB into omega 2. Now here we are coming across very interesting fact about ICR, that is Instantaneous Centre of Rotation, link 2 or body 2 or ladder is having pure rotational motion about ICR I12 or I, but point A of ladder is not going to trace any circular arc with radius IA or I12A, because as that ladder is falling down, point A of ladder will trace vertical line as it will slide against wall in downward direction. Similarly, point B of ladder is not going to trace any circular arc with radius IB or I12B, because as that ladder is falling down, point B of ladder will trace horizontal line as it will slide against floor or ground towards right side. As point A and point B of ladder are not going to trace any circular arc, hence ladder or link 2 is not rotating about center I12 or I at this instant. Hence here we can assume link 2 or body 2 is having pure rotational motion about ICR I12 or I at this instant, but it is not rotating about ICR I12 or I. It looks quite contradictory, but even with this limitation, ICR method is very useful for kinematic analysis. Upper end of ladder will slide in downward direction against wall, and lower end of ladder will slide towards right side against floor or ground. After some time, ladder will take new position A dash B dash. Velocity at point A dash, that is VA dash, will be in downward direction, and velocity at point B dash, that is VB dash, will be towards right. Now for this new position of ladder or link 2, we will locate ICR for relative motion between body 1 and 2. Let us say that ICR is I dash or I dash 12. How to locate ICR I dash or I dash 12? We will draw line perpendicular to VA dash. Now we will draw line perpendicular to VB dash. At the intersection of these two perpendicular lines, we will have ICR I-12 or I dash. By observing I-12, VA dash and VB dash, we will come to know that link 2 or body 2, that is ladder, will rotate in anticlockwise direction at this instant about ICR I-12 or I dash. Body 2 or ladder is moving relative to body 1. Body 2 is having pure rotational motion about center I-12 or I dash. If it is difficult to imagine, then we can assume any shape for body 2 and still it will rotate about ICR I-12 or I dash. Because links can have shape in any manner, or we can assume body 2 as a part of circular disc which is rotating about ICR I-12 or I dash. Or we can assume body 2 as a sticker which is pasted on circular disc, and that disc is rotating about ICR I-12 or I dash. Now consider point C dash on ladder or link 2. We are interested in velocity at point C dash, that is Vc dash, and it will be given by relation Vc dash is equal to distance between I-12 and C dash multiplied by omega 2 dash, or we can have relation Vc dash is equal to I dash C dash multiplied by omega 2 dash, where omega 2 dash is instantaneous angular velocity of link 2 or ladder. Vc dash will be in direction perpendicular to I dash 1 to C dash or perpendicular to I dash C dash. Similarly, we can write relation for velocity at point A dash, That is, VA dash will be equal to I dash 1 to A dash multiplied by omega 2 dash, or VA dash will be equal to I dash A dash multiplied by omega 2 dash, and it will be perpendicular to I dash 1 to A dash or I dash A dash. In the same manner, we can write relation for velocity at point B dash, that is VB dash will be equal to I dash 1 to B dash multiplied by omega 2 dash, or VB dash will be equal to I dash B dash multiplied by omega 2 dash, and it will be perpendicular to I dash 1 to B dash or I dash B dash. Initial position of ladder is AB. As ladder is falling down, ICR I12 for relative motion between body 1 and 2 is shown. After some time, ladder will have position A dash B dash. For this position A dash B dash, ICR I dash 12 or I dash for relative motion between body 1 and 2 is shown. As ladder is falling down from initial position AB, before touching ground, ladder will have infinite number of positions in between, and for every position of ladder we will have ICR I12 or I at different locations. Means whatever ICR we are having for any position of ladder, it is only for that instant. In the next instant, position of ladder will change and ICR will also change, as center of rotation will continuously change from one instant to next instant. Therefore, it is known as instantaneous, I repeat, instantaneous center of rotation.